All right, we're looking at Unit 4 test review today. All right, first thing we have, this graph right here. Is this a function? What's the domain? What's the range? Well, to tell if it's a function, you do the vertical line test. Vertical line test. If you can draw a vertical line and touch it 2 times or more, it's not a function. It can only touch it once. So if I look at here, any vertical line I draw, I'm only going to touch this once. So yes, this is a function. What's the domain? Well, this is a parabola. And as it goes on the left side, it goes to the left forever. And as it goes right here to this right side, it goes to the right forever. So this is negative infinity to positive infinity, my domain. The range is up and down. Well, it goes down forever, so it goes negative infinity, but it goes up to this value right here, which is 4, and you do include it because 4 is part of the domain itself, or part of the range itself, so we do include it. Okay, here's one that's concave up. Is this a function? Yes. No matter where you draw a vertical line, you'll touch it once, so yes, it is a function. What's the domain? Every one of these is negative infinity to positive infinity. Every one of these parabolas. What's the range? The furthest down it goes is right here, 3. And you do include it. The furthest up it goes, infinity. Okay. What about this function? Or this graph? Is it a function? Yes, it is a function. Because no matter where you draw a vertical line, you'll only touch it once. Okay, what's the domain? Domain is left and right. It looks like it starts right here at 1. 1's the furthest to the left, and we do have it included because that's colored in. And then it goes to infinity. My range is up and down. As this thing goes this way, it's going down forever. So it goes negative infinity. Furthest up, right here it stops at 4. And it does include it because it's colored in. Okay. What about this one? Is this a function? No, because if I draw a vertical line right there, well, it's not a very good vertical line, but I can draw a vertical line and hit it twice, so no, it's not a function. What's the domain? All right, left and right. Looks like the furthest it goes to the left is this value right here, -5. And it's included because there's a point right there. And then the furthest to the right it goes is right there, -1. So there's my domain. My range is up and down. The furthest down it goes is -3. The furthest up it goes is 7, and they're both included. So there's my range. Okay. Domain is left and right. Range is up and down. You always have your lowest value, highest value. Lowest value, highest value. Okay. What about this one? Is this a function? We just have points plotted. All right, well, is there any way you could draw a vertical line and hit 2 of the points? No. So this is a function. Every vertical line will only touch 1 point. At least, at the most. And it cannot touch 2. What's the domain here? All right, it looks like left and right. We've got -4 here. We have to list these individually since it's just individual points. This is -3. Right here we got a 0. Then right here we got a 2. And then all over here we got a 7. And they go in braces like this. That's the domain right there. Okay. What about my range? The range is up and down. So my up and down values. All right, here's the range right here. We've got to list them individually. So going down first, looks like the lowest we go is -5. And then we're going up right here to -3. And then the next one right here is at 2. And then we're up here to 6. And then the last one's up here at 7. There's my range. Okay, here's another one. Is this one a function? Okay, look for where you can draw a vertical line and hit 2 points. Right here, look here. A vertical line would touch those, so no. It's not a function. What's the domain? All right, domain's left and right, so we got a value here at -4. We got a value right here at -3. Here's one at -1. Here's one at 1. And then both of these are at 3. So we only list it once. So there's my domain. Okay. What about my range? My range is up and down values. So like here, it looks like we've got 2 at -3. We only list them once. And then we've got one right here at 1. And then here's 2, 3, and 5. So there's my range. That's my range right there. Okay. What about this one? Is this table here, is it a function? Let's see, I've got -4 paired up with 4. I don't see -4 paired up with anything else. -2, 0, 2, 4. Yes, this is a function. What's the domain? Here's my domain right here. And my range, here's my range right there. So I would list those out. I'll not write them. But this one, is this one a function? 0, 2, 4, 6, 8. Yes, this is a function. Here's my domain. Here's my range. I don't have one that's not a function. Here, let me show you what's not a function. If I have my x's and my y's like this, and say I have 2, 5, and I have 3, 7, 4, 6, 1, 9, 2, 8, 5, 4. This is not a function. Why? Because right here, I got 2 paired up with 5, and then here's 2 paired up with 8. This is not a function. So that's what you're looking for to know if it's not a function. When you have 2 x values, or 2 of the same x value with 2 different y values. That's not a function. We didn't have it over here like that, so this was a function. What about this? Here's ordered pairs. Is this a function? Okay, so 3, 2, 4, 6. Don't look like I have a repeat on my x's. So yes, this is a function. What's the domain? It looks like, I like putting them in order, but you don't have to, but 2, 3, 4, 6, 7. This is my domain. See, 3, 2, 4, 6, 7. Now my range is the y values. So I got a 5 and a 5. Look here, I've got 5 repeated, but that's okay if it's a y. So I got -1, 2, 5, and 8. There's my range. And see, I had 5 twice, but only list it once. Okay. What about this one? Is this a function? All right, 5, 3, 8. Oh, 3 again. Look here. No. It's not a function. What's the domain? I got 5, 3, 8, 3, 2. So I got 2, 3, 5, and 8. There's my domain. Then my range is my y values. Let's see here. I got 2, 7, -6, 2, and 9. So we got -6, 2, 7, 9. There's my range. Okay. All right, here's one here. Is this a function? What's the domain and the range? Well, no matter where I draw a vertical line, I only hit it once. So yes, this is a function. What's the domain? Okay, the domain goes from, looks like 1 here, all the way to 5. And if 5's included, see that? So I'm gonna put a bracket. There's my domain. Now, see here, we can't list all these values like here, see? Here we listed all the values and we put these braces on it. In this right here, we can't, man, because there's like infinitely many points in between those. We can't list them all, so we just do this interval. It goes from here to here. It starts at 1 and it goes to 5. Every value in between there is in my domain. My range is up and down, and it starts at 1 here, and it also goes to 5. So it's the same thing. Here, let me draw one that's a little different. Let's draw one right here. Okay. What's the domain range of it? All right, so my domain, it starts at -6 and it goes to -3. So I'll just write right here, -6 to -3. -6 is included, so I put the bracket. -3 is not, so I put parentheses. There's my domain. What's my range? All right, range, it goes from 1 up to 6. It goes from 1 up to 6. Starts at 1, which is not included, and it goes all the way up to 6, which is included. And there's my range. Okay? What about that one? That's kind of like what we just did. What's the domain and range here? So my domain, it goes from right here, -2, and it goes all the way over here to 3. And they're both included, so I put the bracket. That's my domain. And the range, it starts down here at -1, and it goes all the way up here to 4. Oops. And they're both included. That's a 1. And yes, this is a function. All right. Now we're going to go to inverse. Determine the inverse of this function. Okay. Now there's 4 steps. The first step, we change this to y. And then we swap this first step. Then step 2, we swap x and y. So I put x here, and I put y over here. First 2 steps are easy. I change this to y, and then I swap x and y. Now step 3, I solve this for y. So to solve it, I'm going to have to -1 on both sides. Now I have x -1 equals, this goes away, and I have -1/5 y. Okay, now right here, I got -1/5 y, so I got to divide by -1/5. It makes these cancel, and now I have y. Okay, so I have -1/5. There's, see this negative right here, -1/5 y. I got to divide both sides by -1/5. Now, when I divide by this fraction, this -1/5, okay, we should learn this in the elementary school. Keep, change, flip. When you divide fractions, you keep the first one. So I'm going to keep this one here on top, x -1. I'm going to change to multiply now instead of divide, and I'm going to flip this one. So -1/5 would flip to -5/1, or just -5. Okay, that's what y equals. And then I distribute that. So -5 times x is -5x. -5 times -1 is a +5. There you go. And now step 4, we change this to f of x, and f inverse of x. And there's my inverse right there. Okay, so there's a few steps involved in doing that. Here's another one. Let's do another one, okay? What's the inverse here? Now this one's not as hard because this fraction here made this little keep, change, flip thing we had to do. That made it a little bit harder, but this one here is a little easier. Okay, I change this to y. Then that's step 1. Then I swap x with y. Okay, so I swapped x to y and y to x. And now step 3, I solve for y here. All right, to solve for y here, I'm going to solve for my y. Okay, that means I'm going to have to -7 first, and that'll go away. So now I have x -7 equals -3y. Okay, so I'm going to divide by -3. Let's make this cancel. So y equals x -7 divided by -3. Okay, now what we can do here is we can split this up. So this is 1x over -3, so I have 1 over -3 with x, minus 7 over -3, which the two negatives will make a plus. And so there you go, there's my inverse right there. Or we could just leave it y. Sometimes we just leave it y. But that's the inverse right there. Okay, so these two right here are inverses of each other. It's kind of a big deal We're just learning how to do it, and we may talk more about that later as we get into some bit harder stuff. Now here you go. Determine if these are inverses of each other. Okay. Now, to do that, we got to do f of g of x, or we can do g of f of x. Either way, whichever one you think is easiest. But either way, I should get x. I should get x. So what I'm going to do is I'm going to take the g function, put in the f function, or vice versa, the f function and put in the g function. Okay, so it don't look like there's any easier way to do it. So I'm just going to take this top one here, f. I'm going to put f in the g one. So I've got 4 minus 5 halves, and then right here's x. See right there? 4 minus 5 halves x. 4 minus 5 halves x. And then right there where x is, I'm going to put this other one in. Okay? So right here I'm going to put negative 1/2 x plus 4/3. And then I should be able to simplify this and get x if they're inverses. This looks kind of sloppy here. I don't think it's going to work. I can just tell you I don't think it's going to work. But right here I got negative 5 halves. See, negative 5 halves in front of this, I'm going to have to distribute this. You can use your calculator if you want to. When I do negative 5 halves times negative 1/2, I'm going to get positive 5/4. Then when I do negative 5 halves times positive 4/3, I'm going to get negative, let's see here, 10 over 3. All right, this goes with this. And I can already tell, man, it's not going to, see, these are not going to cancel, and I'm not going to get rid of this anyway, so this is no. They're not inverses. Oh, sorry, I didn't, yeah, I think I had it on the screen. It'll fall in place if they are inverses. Let's get one it is. Oh, well, here's another determine if they're inverses. We kind of got out of order here. Let's go, we'll come back to that one. Here's one here. Determine if these are inverses. I think these are inverses here. So what I'm going to do is, now I think it looks easier, this one here, 2x minus 5. And I'm going to take the other one and I'm going to put it in there. So right where x is, I'm going to put the other function. Okay. Now when I distribute my 2 here, with this 2, when I multiply it here, there's a 2 dividing. So they'll just cancel each other. So that means I have x minus 5 in here. Minus 5. Oh, this was a minus 5. So look here, this is x minus 10. So no, they're not inverses. Now, had this been a plus right here, had that been a plus, then I would have negative 5 plus positive 5. They would have canceled, and it would have just been s. They would have been just x, and they would have been inverses then. So you got to watch out for that. So I even was looking at it, speculating at first that they were inverses, but they weren't. But if that was a plus, they would have been. Okay. Now let's go back to this one here. Determine the inverse of this function. Now there is one like this on the test. It's a little tricky. Okay, there's a little tricky aspect to it. So first I'm going to change this to y. And then I'm going to swap x and y. Okay, so here's step 1, step 2. All right. So these first 2 steps, I change this to y, and then I swap the x and y. All right, now step 3, I have to solve for y here. Well, see, all this is divided by 2. So the best thing to do would just be multiply both sides by 2 and cancel this off. So that means I have 2 times x equals, and I got negative 15 plus 3y. Now this is a tricky one, and it's on the test, so pay attention to this one, and it's on the review. All right, so now I'm solving for y, so I'm going to have to add 15. This will cancel off, so I have 3y equals 2x plus 15. And now all I do is I divide by 3. All right, so y equals 2x plus 15 all divided by 3. Okay, now this answer is listed. But really, this is, I'll get it on the screen here. This answer is listed, I believe, but it's a trick because I don't think that's the answer at once because it's not simplified fully. So what I do is I would split that up. So I've got 2x over 3, so 2x over 3 plus, I would have 15 over 3. Okay, that's what y equals. So I've got 2x over 3 plus 15 over 3. Okay, and then so this is just 2/3 x plus, and then 15 over 3 is a 5. So this would be my inverse right there. So this is simpler than that right there. So don't choose this. So this, I think, is a choice. It's a trick question. It's not simplified. I think that's what you want right there. Okay. All right, let's go to this right here. We're finding some function values here. So f of x is this, g of x is that. Find the value of f of 6 over g of -2. So f of 6, I'm going to put 6 in here. So I'm going to write over here first. F of 6 equals, I'm going to put 6 in there. So I've got 3 times 6 plus 7. All right, so I'm putting 6 in the f function there. 3 times 6 plus 7. So it's going to be 18 plus 7, which is 25. Okay? That's on top. Now I got g of -2 on the bottom. So I'm going to write over here g of -2. Okay, so here's my g function. I'm going to put -2 in there. So I've got -5 and then -2 and putting it in for x plus 4. So I'm taking my -2 and I'm putting it in for x here. This is going to give me a positive 10 plus 4, which is 14. All right, that's on the bottom. So 25 over 14. Now we can change it to a mixed number, which 14 goes into 25 one time with 11 left over. So there you go. Okay. All right. Find the value of f of -5 and g of -2 if f is this and g is that. All right, so we're just going to do right here. F of -5, I'm going to put -5 in there. So I got 3 times -5 minus 4. Okay, f of -5, I'm putting -5 in right there. So that's going to be -15 minus 4 is -19. There you go. Now I got to do g of -2. So g of -2, so I'm going to put -2 in there. So I got 2 times -2 squared minus 21 times -2. I'm running off the paper here. Okay, so I'm doing g of -2. I'm putting -2 in there. So 2 times -2 squared minus 21 times -2. Okay, that should be that's a minus right there. All right, so you can just type this in your calculator, or you can do your order operations. So this is going to be -2 squared, which is 4. You do those first. So it's 2 times 4, and that'd be plus 42 here, and that's going to be 8 plus 42, which is 50. Now there's nothing wrong with just typing in the calculator. So here's the calculator. Okay. All right, so if I type that in, I'm going to have 2, and then I'm going to have -2 in parentheses squared. Oh, I hit 5 for some reason. Minus 21, and in parentheses a -2 again, and look there, 50. So we did it right. Okay. Now look at this. We got g of x is this function, h of x is that function. Find g plus h of x. All right, g plus h of x, that's g of x plus h of x. So all I'm going to do is I'm going to add these two together. So I'm going to have 5x plus 3. There's g of x plus, and then h of x is this one. I'm just going to add them together. So add my like terms. Well, start with the highest power. There's x squared. Then go to my x term. Well, there's only one of those. And then my constants, well, these two go together. So 3 plus 6 would be 9. So there you go. There's my answer. Okay. Here's one here. F of a and g of a. find g minus f of a. Well, all right, that's g of a minus f of a. That's what that means. So I've got to do g of a. All right, g of a right here. Make sure you get the right one first, okay? G of a is first, so a squared minus 4a minus f of a, which is negative 2a minus 3. Okay, so here's g of a minus f of a. All right, when I have a minus, awful things happen there, so I'm going to distribute my minus into this expression here. So I'm going to change it to plus. That's going to change it to plus, and now I can add them. That's the thing to do because it'll cause you to make mistakes if you don't do that. So I've got a squared, or he's first. And then now these two go together. So negative 4a plus a positive 2a would be a negative 2a. And then here's my constant. So there you go. There's my answer. Okay. All right. We've got here g of x, h of x do... All right, this is g times h of x, which is g of x times h of x is what that means. So I'm going to have g of x, x minus 6, times h of x, x plus 8. I'm going to multiply those. And the best thing to do is just build you a box. You got a column for the x, you got a column for the negative 6, and then we'll take this to the side. So I have a row for the x and have a row for the plus 8. Okay, so right here, this is x times x, which is x squared. In this square right here, I got negative 6 times x, negative 6x. Down here, I got x times 8, which is 8x. And in this one, I got negative 6 times 8, which is negative 48. Okay, now usually when you do this box, diagonally right here are your like terms. So I've got x squared, negative 6 plus 8 would be positive 2x, and then I got minus 48. And there's my answer right there. Okay. All right, you're looking at this one now. G of t and f of t. All right, find g divided by f of t. All right, so this is going to be g of t divided by f of t. That's what this is going to be. So g of t is on top. F of t is on the bottom. All right, then we simplify it. Well, when you divide like this, you're dividing by all this down here. So there's really no simplifying you can do. So that's it. So that was easy, wasn't it? All right. H of t and g. All right, we're doing h of g of t. This is a composition, so I got to do g of t, which is right here, and I got to do h of that, which means I got to put this in the h function. So here's my h function right here, 3t minus 7. See, there's my h function. I got to do h of this. I got to put that in for t of the other function. And so now I distribute. So 3 times 4t would be 12t. 3 times 5 would be 15. And then minus 7, and these two are like terms. 12t, 15 minus 7 would be 8. 12t plus 8. That'd be it. Okay, we got a few more of these. Excuse me. We got g of x and h of x. Find g times, all right, we're multiplying again. So this is going to be g of x times h of x is what that is. So here's my g of x times my h of x. Okay, I think we just did this page. We had a repeat somehow. So we've already done this. It's x squared plus 2x minus 48. I don't know how that happened. Okay. All right, here's g plus f of x. Okay. Did we do this one? No, we did one similar, but we didn't do this one. All right, so this is going to be g of x plus f of x. So here's g of x right there, plus f of x is this one. So we just add our like terms. So x squared's first, and then my x term would be plus 4x, and then these are like terms, so 2 plus negative 9 would be negative 7. Okay. What about here? We got g minus h of x. So this is g of x minus h of x. So g of x is first, minus, and then h of x will be second. You got to be careful when you do minus that you have the right one first and the correct one second. So correct, G and then H. Because I'm going to distribute this minus through here, see? So that's going to make this a negative, it's going to make that a plus now. And then I can add. So when I do this, my like terms, highest power first. And then I got a plus 2x, and then I got a negative 7 plus a positive 5, which is negative 2. And there's my answer right there. Okay. What we have here now, we got g times h of x. All right, so this is g of x times h of x. It's supposed to be times. So this guy first times this guy. Okay, we're going to multiply these. Well, I'm going to build me a box again. Okay, I got a column for the x squared, a column for this. I'm going to take the x plus 5 to the side. So right here, this is x squared times x, which is x to the third. This is 4x times x, which is 4x squared. X squared times 5 is 5x squared. And then right here, I've got 4x times 5, which is 20x. So with my highest power, x to the third, these two are like terms. They're both x squared, so 4 plus 5 would be 9. And then I got a 20x. There's my answer right there. Okay, after you fill in all the squares, you just add your like terms. And these are the only like terms, so I add them together. 5 plus 4 is 9. Okay, hey, we're almost done. Almost done here. We're doing g divided by f of n. All right, so this is going to be g of n divided by f of n. So g of n's on top, and then f of n is on the bottom, and there's no simplifying you can do, so that's just it right there. The divide ones, man, are easy, aren't they? All right, here we go. We're doing h of g of x. So right here, g of x is x squared plus 8. I got to do h of that. So here's my h function, x minus 8. See there? There's my h function, x. And right there where x is, this goes in. So I'm going to put x squared plus 8 in for the x. Okay. So it looks like 8 minus 8 cancels out. That's just x squared. How about that? That was easy. And then one last one here. Last one. All right, now here we're doing f of g of 3. So right here I got to do g of 3. So g of 3, here's my g function. 7 times 3 plus 5. All right, that's 21 plus 5, which is 26. All right, so this is 26. So now I got to do f of that. So g of 3 is 26. Now I got to do f of 26. So f of 26 is going to be, right here's the f function. I got negative 9 times 26 plus 8. All right, negative 9 times 26. 9 times 6 is 54. 5, 18, 2, 34, negative. Okay, I just did it in my head. Now you can just punch in the calculator. This is going to be negative 234 plus 8, which is negative 226. Okay, now right here, you could just punch this in the calculator. Let me just do it real quick. Say negative 9 times 26 plus 8. You just type it all at one time, negative 226. See there? So I was right. And that's it. So Unit 4 test review. Study up for this test and make yourself ready and do good. Make 100. If you need help, just yell at me anytime. Have a good rest of the day. Bye-bye.